Hi everyone, how is it going? So welcome to my complete Python crash course for beginners. So in this crash course, I want to cover everything that you need to know in Python as a beginner before you move further to take other more advanced courses. So at the end of this tutorial, I should be able to cover the entire basics of Python so that you can move ahead and then take other advanced courses that are specific to what you want to do. So at the end of this course, maybe you should be able to take another course that might lead you to become a web developer, or other course that might lead you to become a data scientist or a machine learning expert. But for this course, we will just go over the basics of Python so that you understand the syntax, the entire ecosystem of how Python works in our system. So the first thing you need to do is to install Python into your development environment or into your system or your laptop or your desktop. And you can do that by simply coming to this website, which is python.org, and then it will redirect you to this page. When you get here, simply go click on the download tab, and you should see an icon to install Python right here. So downloading this into your system, you will simply run it based if you're using a Windows system or a Mac system or a Mac OS. You can simply install it the way you install other packages that you download from the internet. So after installing this into your system, you can test and see if Python has been installed by going to your terminal and running something like this, Python, running maybe Python. So to check this, so once you click Python on your terminal, you should see something like this. For instance, I have Python 3.11.5 installed in my system. So you should be able to see something like that in your system. So you can now quit and then leave this particular point. Now the next stuff you might want to download is a text editor. So as you can see, I'm using VS Code, which is one of the most popular and free text editor that is offered by Microsoft. But you don't really need to use my VS Code like I'm doing. You can also use something like Sublime Text, and you can also look for that on your browser. So if you type in Sublime Text on your Sublime Text on your search engine, you should see Sublime Text, which is also another very good text editor that is available for writing code. But if you want to use VS Code like I'm doing, you can also type in VS Code and you should see a link like this, the download link for you to download VS Code in your system. I'll also drop of the link to download this software inside the description of this video. Also, if you want to get the entire code that we are going to use in this video, I'll also drop a link to the repository under the description of this video. So you can simply go there and clone the repository or download the repository depending on how you want to do that. So if you've successfully done all of this, let's go directly into our system and see how to do this. So the first thing we want to do is to learn what is a variable in Python. The first thing we want to do is to learn a variable. And as you can see, I've actually arranged the entire directory of this tutorial in an orderly format that you can easily look for or find whatever you're looking for. So the first thing we are going to look for is a variable. So a variable has different meaning, but generally a variable is used to de dedicate a particular memory location for a data. Okay, so a variable is like a memory location, a name given to a memory location that we'll be using in your entire program. So for me, I define as a name given to a memory location. Okay, because the reason why variables are important is because our system has a lot of memory space. Okay, every simple gadget you use or you have has millions or even thousands of memory location. So the way you are able to assign a particular location to a particular object, to a specific object, is by giving a name to that particular object. And in programming, this is called a variable. Okay, so in Python, the way you define a variable is simply write the variable name. Let's say, for instance, you want to create a memory location for storing age. So you can simply write age and then assign the data that you want to store in that memory location. In this case, we now say age is equals to 23. So across our program now, wherever we see age or wherever age is being called, it will be given or it will print out the value of 23. And we can prove this by using one Python Python function or a function that Python gives to us, which is a print. Now, a print statement in Python is actually used to output something to our terminal. So if we actually want to see the value of this age, we need to put it in a print statement. So in this case, if we say print age, and then we'll come to our terminal now, come to our terminal, and let me clear what is there already. So if we come to our terminal now, first of all, we have to see we have to move into the folder where the variable is located, where the file is located, which is at one dash variable. Okay. So while we are inside there, we can now run this particular Python file. And the way we run a Python file is to simply say Python, then space followed by the package name. So we can now say variable.py. So if we do this now, you should see age being printed out for us in our terminal. Okay, so let me save this again. Let me save this and try to run that again. So if I do that again, and now you can see that it prints out 23. So this variable or this particular variable now holds the value of 23. Now our systems and as well as our entire code now realize that any variables or any time we call the variable age is going to print out something called 23 or any other data that is being stored in that particular place for us. Okay, so that is the beauty of a variables and how you can use them. Now, one advice I can give to you while creating variables, because you're going to create a lot of variables that host different types of data. The the recommended approach is to always, or the professional approach I should say, is to always use a descriptive name to name your variable. So for instance, if you want to store food items, so it's better for you to actually call it as food items, and then followed by the data you want to store in that particular place. So that when you come back to your code, or if somebody else is looking at your code, the person will easily understand what kind of data is being stored as this food item, okay, by just looking at this. All right. Okay, and then there are different ways you can actually structure your variables. In Python, the recommended approach in Python is to use the snake case approach. So you start the first name of the variable in small letter, and then you separate each of them by underscore. So instead of writing food item like I wrote before, you can simply say food items. Okay, so Python actually use snake case for its naming convention. All right, but you can also use something called camel case. Camel case is to start the first word by small letter, and then subsequent words that follow should be in capital letter. All right, so that is also very acceptable, but this is the recommended approach in Python. But this also works very fine, as this is what I often use since I program with other programming languages as well. All right, and then one thing you should also know when naming your variable is that Python is a case-sensitive programming language. What that means is that if you name something like this, food items, food item, and then food item, food item. In Python, these are two different data entirely. You can see that this one starts with a small letter, while this one starts with a capital letter. In Python, Python is very, very case sensitive. So if you name this kind of stuff and then you now name it like this, these are two different data according to Python, and don't confuse any of them. So that makes it a case sensitive programming language. Unlike other programming language where these two things can mean the same thing. In Python, this is very much case sensitive, and they mean so different stuff. Okay, so we've covered how to define a variable, We've also shown how the naming convention in Python, and then um, we've shown you that I've actually shown you that Python is actually very much case sensitive. One more thing that I'm supposed to have said at the beginning of this video, but I missed out, is that Python is an object-oriented programming. When we get to classes, this should be very much better when explaining it. But in simple terms, it simply means that unlike some programming languages that are available today, Python can actually be used to model something like an object and stuff like that. So Python is an object-oriented programming language, which is a very, very important concept in computer science and programming. Also, Python is an interpreted programming language. What that means is that Python does not require you to actually install something called a compiler. Now, in other programming language, a compiler is what compiles your programming language into the language that the computer will understand. But Python does not require you to have a programming language since it is interpreted, and the system that you're coding in can simply understand Python immediately. Okay? Now, Python can be used for a whole lot of stuff like data science, which is essentially what Python was created for in the beginning. And then it can also be used for web development because of the available of a lot of frameworks like Flask, Fast API, and Django. And then Python is used exclusively and very greatly in machine learning and artificial intelligence. And then you can also use Python for automation. Okay, so Python can do a lot of stuff. All right, this is something I'm supposed to have said before even going to variable. I'm sorry I have to bring you back to this point. Okay, so after variable, the next thing we want to look at is operators in Python. Now, there are basically two types of operators in Python. The first type is comparison operators. Now, comparison operators are used to compare to one variable to the other or one item to the other, while arithmetic operators are used to perform arithmetic operation. So let's see how this works. Now, if I create a variable, if I have a variable called number, or I have a variable called score, and it's equals to, let's say, 90, and I have another variable called score2 equals to like 85, equals to 85. And these are two variables that I've created. One is score, okay, this is the score2, and this is score2, which is 85. Now, there are comparison operators that you can actually use to compare if these two numbers are the same, greater than, or less than. So let's try and see how to compare if they are the same. So if we use the print statement that we used previously again, we can now do something like score equals score2. So score equals score2. So with this double quotation, double equality sign, we are simply comparing one variable to the other. All right. We are simply asking the system, the score equals to score is actually equals to score2. Now this is different from when you do something like this. When you do something like score equals to score2 equals to score2. Now in these instances, in this second instances, what you're doing is that you're assigning the value of score2 to score. Okay, you're assigning the value of score2 to score. While in the first instance, you're comparing if score2 or score is equals to score2. So let us print this out by running it and see what it will give us. So first of all, move away from the current file. Move away from the current file. And we'll move into the second folder, which is 2. So we can now run operator.py, and then run this now. Okay, I think there's a mistake there, so it's operators, not operator. So it's operators.py. So from here you can see we have a key error here. They say score is an invalid key argument for print. So let us remove this right now. Let's remove this and then save this now and then run it again. So So you can see we get false here. I think I need to clear my terminal and run this again so that it can be very clear for you to see. So if I clear my terminal now, then I can run this again. So you can see false here, which is telling us that when you compare score to score, it is not equal to this. So it's going to return false for us. But if we change this now to be 90 also, if we change this now to 90, when we compare the two of them, and then we'll come here and do that again, we'll compare the two of them, you will see that we now have true, because when we compare these two numbers, they were actually equals to. All right. Now, another thing we can do is to check if score is greater than score 2. Okay. So we are now saying score, is it greater than score 2 in this instance? So we should also have true now. So if we run this again, we have true, which is here because score is actually greater than score 2. Okay. So we can clear our terminal again. Now the next thing you can actually do here is if it is greater or equals to. Okay. So if something, this actually say if it is greater or equals to, then it will return true, else it will return false. So if at least score is greater than score 2 or is equal to score 2, it's supposed to return true, else it will return false. So if we run this again, let's see what we are going to have now. So if we run this again, we have true because score is actually greater than score 2. If it's actually equals to score 2, it's going to actually return true. Now the next one we can use is actually less than or less than equals to. So this is just like the inverse of greater than. So in this case now, if we run this, you can see that it's going to return false, because it's going to return false, which is what it returns here, because we are saying here that score is less than or equals to score 2, but in actual fact score is actually greater than score 2. Okay, so those are actually the basic comparison operator that we have in Python. So we have the double equals to, which is used to compare if a number is actually equals to the next number, or if a variable, even if it's a name, it actually equals to the next variable. Okay, so what we are actually comparing here is not the variable itself, but we actually compare the data that is being stored in the variable. Okay, that means even if the data here is a string or any other data type, we can actually compare both of them. All right. Okay, so the next one we've actually looked at is greater than and greater than or equals to, which is used to check if a variable is greater or equals to the next variable. Another one is less than and less than or equals to, which is the inverse of this particular one. Okay, so those are the basic comparison operator that we have in Python. The next one we have to look at right now is the arithmetic operator. So the arithmetic operators enables us to perform arithmetic operation in Python. So the basic arithmetic operation in Python that we have is addition. We have addition, which is given at the sign plus. We have subtraction, which is by the sign minus, and we have multiplication, which use the asterisk in your key. So which is asterisk. Usually shift 8 should give you that. And then we have the division, which is the normal division, and then we have the modulus. Now the modulus is given by a percentage sign. Now, and it's perhaps quite important because kind of usually give confusion. So the modulus is just like a division, but instead of giving you the result of the division, it gives you the result of the remainder. So it's actually used to find the remainder of an operation. So let's say we have something like results. Let's say we have a variable like results, and we say 10 divided by 10 divided by 3. Okay, let's equal this to 10 divided by 3. So if you print out results now, print out results. If you print results now, let me see if there's any other thing there. Let's uncomment this out. Let's turn this to print. So if we print out this result, what we should have is 10 remainder stuff. So as you can see, we have 10 remainder 10.3333 with decimal places that follow. Okay, so the difference between this and modulus is that modulus will only return the remainder here, everything after the decimal place, but will not return this particular one. So the way you can do that is, let's say result 2 now should be equals to 10 modulus, and like I said initially, use the percentage sign modulus 3. Okay, so if we print out result 2 now, let's see what this will get. Or let me also print out result 1 so that you see the difference between the two of them. So we have result 1 and we have result 2. So if we come to our terminal right now, so you can see that the first one returns 3.111, while the next one return 1. Okay, which is like the remainder of what will remain. So if you divide 3 by 10, what you are going to have as a remainder is going to be 1, because 3 by 10, 10 by 3 rather, you have first 3, you have second 3, you have the third 3, which will give you 9, and then what should be remaining here is 1, which makes it 10. Okay, so we have 3, 3, 3, which is the number of times this guy can go into 10, and what will be remaining is actually 1. Okay, so modulus only allows you to get, or only return the result of the remaining values that comes after computation. All right, so addition is like normal addition, so you can say 10 plus 3. Subtraction is like normal subtraction, so you can say 10 minus 3. Multiplication is 10 multiplied by 3 using the asterisk sign, and division is normal division like I've shown you before. Okay, so those are like the basic arithmetic operators that we have in Python. You can perform other high function computation or operation, but you will need to import a package like NumPy. You need to import a package called NumPy, which is an entire package on its own that requires you to actually learn it different. Okay, all right. So that is the conclusion of the Python operators. Okay, now let us move on to other very important ones like data types. Okay, in programming, a data type is used to specify the type of data that is being stored in a particular variable or in a particular memory location. The importance of knowing the data type that you're using in your programming language is so that you will know the kind of operation you will want to perform. For example, if you have a score of a student, let's say in subject A, let's call this subject A, the student has a score of 23, and then subject B, the student has a score of 10, right? So knowing that these two are numbers, you can simply print out total score of subject A plus subject B, right? And this will give you the sum of these two stuff. But if, assuming this is subject A, and then you now enclose the next one in subject B, this is a different data type from this one. Okay, so in your program, if you try to add this particular number, which is enclosed in a quotation mark, to this one, there might be a problem. Right? The reason why there might be a problem is because the data type for subject A is different for the data type for subject B. So in programming, knowing a data type is very important because it enables you to know what kind of operation you will perform on each type of data, okay, so that there will be no problem. When it comes to Python programming, Python has a lot of data type. The basic one which we are going to look for now before we move to the advanced one is integers, string, and float and booleans. Integer, string, float, and boolean. Now when we talk about integer, an integer is any number that does not have a decimal place. So if we have something like score A, and we equate it to 3 or 23 rather, this is an integer. So any number without a decimal place is actually called an integer in Python. Other programming language might have a different name for this, but this is actually called an integer in Python. But the alternative to this is to have a number. Let's give another variable, we'll call this score B, and we'll give it to something like 23.5. Now, whatever number that has decimal place, any number that has decimal place is actually called a float. So remember this, numbers that don't have a decimal place is called an integer, but the one that has a decimal place is called a float. Now both float and number belong to a single parent class. Both float and integer belong to a simple or a common parent class, which is called num. So the parent class for this is num, which is like a short form for like number. This is like the parent class that both an integer and a float inherit from, okay? Because they are all numbers. It makes sense because they are actually all numbers, right? But when it has a decimal place, that number is of type float. And when it has no decimal place, it is of type integer. For you to prove that this is true, you can use something called type. Python gave us a function called typeof, which is used to check the type of a particular data that you're working on. So we can now come here and say print typeof score A. So if we print type of score A now, let us go to our terminal and see what this will give us. So first of all, we have to move out of this particular folder. Have to move out of this particular folder. Then we have to move into the next folder, which is 3-data types. So inside this -data type, we can now run sorry please, I think I made a little mistake. So I'm going to clear this terminal. Then I want to run python types.py. Okay, so python types.py, and you can see that the method that we have here, sorry, this is type, not typeof. You can see that the class that is printed out here is of type int. That is to show you that this particular guy belongs to a class called integer. If you don't know what is a class right now, don't worry, we are going to look at it in more detail. Now if you bring this print statement now, bring it down, and then change it from score A to score B. Then we'll print out score B, and then we'll run this again. Let's make sure this is saved. Then we'll run this again. So this should print out of float for us, class float. So you can see this is of class float. That is to show you that type or score B belongs to a type of data called float. Okay, so those are like the basic number or basic classification of number in Python. The first one is an integer, that is a number without a decimal place, and the second one is a float, any number that has a decimal place. Now the next type of data that is common, which we will use extensively in this tutorial, is a string. Now a string is any type of data that is enclosed in two quotation, either single quotation or double quotation. Let's say you want to store somebody's name, so you can say name is equals to Samuel. So name is equals to Samuel. Okay, you can see that we enclose this in double quotation, but it can also be single quotation. So you can say name2 is equals to Sophia in this case now. Alright, so this is double quotation and this is single quotation. It doesn't really matter, provided they are enclosed in a quotation like this. This is of type string. Okay, so now you can also test this. Bring the print statement. You can bring the print statement down here, and then we can print out name and also print out name2, so that we can see both of them if they belong to the same class. So if we save this now and make sure that this is on comment, we save this now and we run this. So you can see that this is of type string and this is also of type string. All right. So that is like the third most commonly used Python data types. Okay. So we've talked about integer, we've talked about floats, we've also talked about a string. Now the next one we are going to look at now is a boolean. Now a boolean is quite important because it enables us to do a lot of stuff in programming. Now a boolean is a true or false data type. So it can either be it's something that can either be true or false. In some programming language, they don't use true or false, rather they use something like 1 or 0, but they are the same thing. Okay, true or false. So let's say if you want to check if today is Monday, let's say you're building an application and you want to check if the time is like Monday, or I mean if the date is Monday, or if the time is like 8 p.m. Maybe you're building an application that for someone to set a reminder and you want the reminder to be going at a specific time. If somebody creates a reminder that should go off at 8 p.m., you can use a boolean to like check if it is Monday and the time is correct. So you can do something like it's Monday, and you can now set it to data type like true. Okay, if today is Monday, this will print out true. If it is Tuesday, if it is Tuesday, so you can actually set this to false too. So false. So essentially, this data type is used to check when something is true or when something is false. Okay, and then usually it accompanies by a different another operation. So if it is true, then it can actually do something. If it is false, it can actually also do something. So a boolean is a true or false data type. So whenever a data is set to true or set to false, we call that type of data a boolean. Okay. In other programming language, you can say something like bool, 0, 1, and so on and so forth. That is actually a boolean data type. So in this particular section, we talked about an integer, which is a data type without a decimal place. We also talked about float, which is a data type a decimal place. Okay, even by just highlighting it this way, you should see that a variable score B of type float. If you also highlight it this way, you can see variable score A of literal or whatever of integer. All right. Then if you highlight this, you should see that it's a string. We highlight this too, also a string. Okay, and then and so on and so forth. Okay, so in this section we talked about different types of data, but there's other one amazing thing we can do with a data. So let me open. You can now go to this section called casting. Now, what casting does is that it enables you to convert from one data type to the other. So if we go back to our file, which is type.py, we can now copy these two variables that we define here. Let's copy these two variables and go back and paste it here. Now, casting allows you to like convert from one data type to another. So for instance, since we know that score A is of type integer and score B is of type float, we can convert each of these type to another type. So we can say something like this. We can say score C, we can say score C, let's define another one, is equals to int score B. Int score B. Int score B. So remember that score B was a float, but by wrapping it with this method called integer, we've actually converted it to an integer. So what will happen now is that when we print out score B, or when to print out score C right now, it will remove the decimal place and just return the whole number for us. Okay. So we are simply, by doing that, we are simply converting, from one type to the other. So let's clear this. Let's run this again. Let's run this again. So this time we want to go to casting.py. So if we run this now, okay, I forgot to print this out. So we are supposed to print score C now. Print score C. Save this, then run this again. Now you can see it's actually printed out the value of score B, but this time around it's removing the decimal place that was there. Now we can also convert an integer to a float by also wrapping it with a method called float. So if we wrap score A now with a method called float, it should convert this particular guy to a float. By what it will do is that it will add 0.0 to that particular function. Okay, to add 0.0 to it. So if you go down here and then we print it out, we should see 23.0. So as you can see, it's 23.0. By adding 0 to this particular number, it successfully converted to a float. That is basically how to convert from one data type to the other by simply wrapping it with methods that are available. There's also another one called string, which converts data to string. Okay, so if we run score C now, we should convert this particular score A to string. Okay, just the way we've done other ones. All right. Now I'm sure you've learned the common data types that are available in Python, and then you are also able to like convert it from one data type to the other. Okay. The next thing we are going to look at is more advanced data types that we have in Python, which is under this folder called collection. So in the next one, this is what we are going to do right now. Okay. So if you come to this folder directory, you should see another directory here called collection. So that is number 4 folder, which is called collection. So the first thing you need to do is to move to that folder. So we'll move out of the current folder, and then we'll now move into 4-collection, which is the next folder that we want to move to right now. So inside that collection, we have different files. First of all, move into the list.py. Now, the list.py, a list in Python is a type of data. Now remember that when we are looking at integers, float, and stuff like that, and string, we actually define something like a score, and then we assign it a value of maybe 90 and so on and so forth. But imagine if you want to store the entire data of maybe 20 or more students in a class. So it will be almost unreasonable to keep creating score 1, score 1, and say 20, score 2, or score 3, or score 3 right now, score 3, and say 40. It will be unreasonable to keep doing this, because if you have 100, maybe 100 students in a class, you might not be able to like do all of this. So in this instance, what you need to do is to create a simple collection where you can store all of this data. So Python gives us a way to do that. And one of the first way we can do this is to use something called a list. So in some programming language, this is called an array, and so on and so forth. But in Python programming language, we call this a list. So the way you define a list is that you write the name of the variable, maybe in this case, scores. Now this will hold the entire score of every student in a particular class, if that is the situation we are looking at. And now we can now equate this to these 2 square brackets. So inside this 2 square bracket, you can now add all the scores you want to add. So let's say you have like 20 students, you can now add all the scores that of 20 students, and so on and so forth. So let's add this. That for 50 again, 60, 80, 100, and you can continue. Now one beautiful thing about a list is that you can store different kind of data type, unlike when we have when we are storing just single type of data in a particular variable. when we are doing list array, when we are doing int, float, and string. But in this one, you can actually store both a decimal, a float, just like here, store an integer, or even store, you can even store a string. So we can come here and store a string and call it maybe Sophia. You can also store a boolean false. You can even store other data type inside of here. For instance, we can store this type of data which we'll talk about. This is either a set or a dictionary. So you can store other type of data type inside, other type of collection rather, inside a list. Okay, but for now, let's just keep it very simple. So as you can see, we've stored a lot of data inside this particular place. Now, how do we have access to each of these data that are now stored here? Now, the way we have access to data inside a list in Python is to use something called index. Now, an index is the position of an item. An index is the position of an item in a list. Okay, so when we talk about an index, we are talking about the position of an item in a list. So this is a score for students in a particular class. So if we want to access each of these score, we can use the index of that item in that particular list. So in programming, an index or the position of a number or of an item rather start from 0. Okay, so let me repeat that again. In programming or in computer science, the position of an item in a list start from 0. So 20 has an index of 0, 13 has an index of 1, 24 has an index of 2, 56 has an index of 56. So if we come here now and say print scores for index of 2, print score, what we are saying here is that print score at an index of 2. So let me show you what that means. So I'm simply saying score square bracket 2. Okay, so this is the same thing that I put inside this print statement. So what this will do is that it will bring any number that is in the index position of 2, right? So if we print this out now, so I have to do python list.py. Python list.py. So you can see it prints out 24 because 24 is in the index position of 2. Okay. So you can actually test it with a different number. So let's say index position of 100. Index position of not 100. 100 is what? 1, 2, 3, 4, 5, 6, 7, 8, 9. So 100 is at position 9. So if we do this now and save, and then we run this. So this should print out 100 for us because the item at an index of 9 is 100. Okay, I hope you get that. So remember that I said that a list, so the way you access a list is using their index position, and an index is the position of an item or the position of an index is the position of item in a list. And this was a mistake. Of an item in a list. Now there are other methods when we declare this as a list. Python gives us the ability to perform several other operations in this list. For example, we can remove numbers, we can remove numbers, we can add numbers, we can do a lot of stuff inside this list without actually adding them manually. Okay, so for instance, because score is now a list, we now have access to a property called or a function called append. Okay, the first one is append. Now what append does is that you can use it to add a new number inside that list. So if we now say append 200, now what is going to happen is that it's going to add number 200 to the end of this particular list now. So if we print out scores now, we print out the entire score list, scores now. We print this out now. You can see that it adds 200 to that particular list. From here, we had first as the last item here, but now it adds a new item. So append is used to add a new item to the end of the list, right? So the next one we can also do, the next method we can use to add is something called insert. So we have another one called insert. But instead of adding to the ending of the list, insert enables us to specify where we want to add it. So using the index position, we can now say that at index 0, we want to add another item. So let's call this item orange. So let's call this item orange. So we can now say insert at position at index 0, insert orange. So if we save this now and we run, you can see from our terminal here that orange has been added to the index position. And so what that will do is that it will push the rest of the item backward and then insert this orange at that index position. Now we have a method of, these two methods is used to add item to the list. We also have another method of removing item from the list. So the first method we have is of something called pop. So pop does not accept any parameter, but it is actually used to actually remove an item from the ending of the list. So remember that the end of our list now has an item called 200. So with pop now, we should be able to return that. And then when we print this out, you will not see 200 anymore there. So if you do this, now, you can see that it returns the last item is false, but from here the last item was 200. So pop is used to remove, just like append was used to add item to the end, pop is used to remove item from the end. But if you want to remove item from anywhere that you want, so you can now say score dot remove. So you now specify the item that you want to remove. So in this case now, I want to remove 56, which was here. So you specify 56 from our list. Okay, as you can see, 56 has actually been removed from that particular list. Now there are other methods that are available with scores. If you simply do scores dot, you will see all of these methods that are available. Like we have clear. Clear is actually used to remove all the items from that list. Copy is used to make a duplicate of that list or other one. Reverse or sort is actually used to reverse. Okay, so let's try reverse and see. So reverse now. Reverse is actually used to change the direction of that particular list. So from here it was first before orange, but now it was first last before and orange first, but now it will change to first Sophia 100, 80, 50 and so on, and orange will be the last item. So if we do this now, so if we run this now, you can see that it has changed the inverse of our item and we start from this part. Now that is what the reverse does. There is another one called sort. So what sort does is that it sorts the item in an orderly manner. So in an ascending order. So you can actually change the reverse of sort. So it's just simply used to sort our item in maybe from, I think in a descending manner. Yes, I think in a descending manner. So if we run this now, okay, so the reason why this does not work is because sort does not work when we have a mixture of data types. So we can now remove, let's try to remove these two, let's try to remove these two string here and also remove this orange, so that our list will now be just a list of integer. All right. So if we run this again, you can see that it has sorted out all the items starting from 13 to 100, which is like in a descending and the ascending order. I don't know, but that is what sort does. It actually sorts the item starting from the smallest to the biggest. Actually, you can actually set a reverse. You can actually set something called reverse, and you can set it to false, and it will change. It will make it start from the highest or the biggest number to the smallest number. Okay, this was set by to false by default. So let's set this to true. If we set this to true now, you can see now it starts from 100 to like 13. This is now in a descending order, but by default it sorts in an ascending order. Okay, so you can set that parameter rather to, and that should work for you. And so that is there are a lot of stuff you can do with a list, but that is just the basic thing that you want to learn. You want to learn how to add item using append and insert. You want to also learn how to remove item using pop and remove. You want to learn how to reverse, to sort, to clear, to copy, create a clone, and so on and so forth. You want to do. That is essentially everything you need to do with a list. Now the next type of data I want us to look at is now you can navigate to the tuple.py file. Is something called a tuple. Okay. Now a tuple is like a list. A tuple is like a list and is defined as, let's say, scores. Let's simply just go here, simply go to here and copy list example here. Okay. Then go back to a tuple. Okay. Right. Now, what we are going to do, we are going to change the structure. Instead of using a square bracket, we are going to use the round bracket. And once we do this, this becomes a tuple. Again, you can actually print out this type. You can say print type scores. You can print type scores. Then if we clear our terminal, so this time around we are going to run python tuple.py. So python tuple.py. Okay, so if we run this now, of course she'll tell you that this is of class tuple because we changed this to a rounded bracket. Now the difference between a tuple and a list is that a tuple is immutable. In programming, when we mention something called immutable, we are saying that it cannot change. Okay, so unlike in a list where we can actually add and remove items, in a tuple you cannot do that. Once an item has been added to a tuple, you cannot remove or add or perform any kind of operation with those items that are added to that tuple. Okay, so that is just like the major difference between a tuple and a list. So to even verify that, you can also do scores dot here, and you can see that you don't have much method available like we had in a list. Okay, that's because a tuple you cannot do most things. So the only thing you can do in a tuple is either you can find an index or you can find the count. For instance, now we can say count of 50. What this will return, it will return the number of times that 50 appears in this tuple. So we can just simply copy this now. Let's copy this. Let's copy this and paste it here. Okay. So let's copy this, sorry. Oops. I don't know why this is not working. I'll try that one more time. I'm sorry. So let's copy this and paste it. Okay, it works now. So count will return the number of times a specific item appear in that tuple. So we do this, you can see it appears, 50 appears 2 times because we have 50 here and we also have 50 here. Okay, so that is one method, or that is one operation you can do in a tuple. But from what you can see, when we do scores dot, there is no other operation that we can do here. There is no other operation. You cannot count. I mean, you cannot add, you cannot remove an item. That is what makes a tuple essentially different from a list. A tuple is immutable, a list is immutable. A tuple is immutable rather, a tuple is immutable, a list is mutable. I hope that is correct, but I hope that pronunciation is correct, but essentially that is what it means, okay? Now the next one we want to look at is a set. Now a set is a really amazing type of collection in Python. So a set is just like a tuple again, or like a list, but the structure kind of differs. And I'll tell you where a set becomes or is really important. So if we paste it here, what we are going to change is to change this structure to the curly bracelet. So remember, for a list it was square, for a tuple it was rounded, and for this particular one it was curly bracelet. Now for a set you can perform most of the operation that you can also perform in a list. You can add item with add, you can clear item, that is remove item, you can copy, find difference, you can update, you can discard, and you can do a lot of other operations. You can even remove item. So it's just like a list. But the major difference between a list and a set is that a set does not repeat a number. It removes any duplicates in a number. I mean in a list or in the collection rather. It removes any duplicate. So you can see that we have 50 here and we also have 50 here, right? But if we print out this, now, print out scores inside this particular place, and this time around is going to be Python set.py. Set.py. Now, if you look at this, you will notice that only 150 is now remaining, and I can simply copy this. Let me copy this and paste it in our screen so that you see it very well. So you can see that in this place now, it has removed one of the 50 which was here, and it's just left with one particular one. Okay, so what a set enables you to do, or what a set does, is that it removes every duplicate that exists in our collection. Okay, so to add numbers to a set, you can use the add method which is available, and then you can specify what you want to add. For instance, you can now add 120, and that will add it to our list. So if you print it out now, print score. I'm sorry because I keep saying list and sets. I keep interpolating both of them. I'm sorry about that. So if you print this out now, you can see that it adds 120 to that particular list, which is to the end of our list. Okay, to see other stuff you can do, and I encourage you to try to experiment with this. You can simply do this and then you will see all of them. If you highlight them, you will see what you can do with all of them. Okay, we have intersection, we have intersection update, we have discard, we have difference update, we have copy, we have clear. Clear essentially just remove everything in that collection. Pop will remove the first item. It's just like the inverse of add. It will remove the first item. Then we have remove to, which will remove at a particular location. And which other one? We have updates, we have union, and so on and so forth. So I encourage you to try to see all of the things you can actually achieve at that particular point. Okay, so we've talked about a list, we've talked about a tuple, talked about a set. The next one we want to talk about right now is a dictionary. Now, Python dictionary is very much used in web development. So if you are planning to become a web developer, Python dictionary is very much in use. Okay, so let's again imagine if you want to store, let's imagine you want to store data of everybody in your family. Okay, let's say you want to store the data of everybody in your family. You want to store both, not just their age, but their name, their height, their complexion, and so on and so forth. You will not be able to do that with a list, because a list simply stores this kind of information the way you see that, right? You also not be able to do that in a tuple or a set, because they store information in practically this straight format. Okay, they store information in just a linear approach, but with a dictionary you should be able to do that very well. Now a dictionary use a process or a style called that some people will usually say key value pairs. Key value pairs. Key value pairs. Okay, and we are going to see what this means. But first of all, let's define the structure of a dictionary. So let's define a variable called family tree, because right now we want to store the information of everybody in your family, and then we equate it to this structure. And now don't confuse this with a set. Right now it's actually a set, but when we start adding information into it, it will actually change to become a tuple. I mean, to become a dictionary. If we save this now and we say type and print out type of family tree, you should maybe print out a set for us. So if we say type family tree, we will print this out, and this time around it will be Python dictionary.py. So Python Python dictionary.py. So if we do this now, if we run this now, it should print out that this is a dictionary for us. Okay, so by equating it to this structure, this becomes a dictionary, right? Now the way you actually add information to this. So let's say now this is a family tree and you want to add you want to collect all the information about the family. So you can now start with somebody's name. So you can now say someone Daniel, right? So follow with a column, and then you can put all the information that this person has. Okay, so this is Daniel. Now you can collect Daniel's telephone number. So telephone number is Daniel's telephone number is what? It's also a string, and you can add 09090, sorry, 09027265100. Okay, that is Daniel's telephone number, and you follow this with a comma, and you can now add the next thing you can now add is complexion, and let's assume this is complexion. Let's assume this is complexion and is dark. And the next thing we can collect is what again? We can collect his height. Okay, collect his height, which is 120. I don't know if this is correct. 170 meter. 170 meter. I don't know if that is correct. Okay, so let's assume this is the information for Daniel. Now we can copy this and give a comma here, and we can add another one, and we'll keep increasing this, and then we'll make a little change later. So this is information for 3 families. We'll call this James. We'll call this, and we'll change the phone number for James, and this should be 07, and this should be maybe 800 and so. And James is fair, and James is 80 meters, right? Of course, you can also add their height, I mean their age. So you can also collect age here, and then Daniel is 35. Remember to always put a comma after each stuff. Daniel is 35. And let's copy this age and add for the 3 family members. So comma here, put this. comma here. And now change this to like maybe 22 rather, and then we can change this to whatever I want to change it to, maybe 7, 8, 9. So now I want to look at the structure of a dictionary and how it differs. Okay, again, we are supposed to change this to Jane, so let's change it to Jane, right? We have three objects here now. We have Daniel, we have James, and we also have Jane. Okay, so a dictionary has a key. Now, a key is this particular name that appears here, because we have to pay attention, because this is what we are going to use to access every other information that exists in this particular dictionary. Okay, so think about like a real dictionary. Think about a real dictionary. When you open a dictionary, you see a word. Okay, when you open a dictionary, you see a word, and then you see definitions of those words, and that particular word can have different definitions. Sometimes can have more than one definition depending on the use context, right? So if you open a real dictionary, you see a word, and then you see the definition that follows. Now, in this Python dictionary, when you open a Python dictionary, you see a key, or sometimes it can be a lot of keys. For instance, we have this particular Daniel is a key, here. James is also a key, and Jane is also a key, right? Now, inside this James, which is separated with a column, you will now see the data that it carries. Now, this data is also another dictionary, okay? It's also another dictionary, but it can as well not be a dictionary. It can as well be a simple, it can as well be a list, okay? It can be a list, which is another data type. It can be an integer. It can be a float. It can even be another simple string like James and then something else like me. Okay, so a key can accept any kind of data type. All right, a key can accept any kind of data type. I just wanted to show you the complication or the complexity that it can go to by using a dictionary. So this is a dictionary of keys that also take another dictionary. Okay, now what dictionaries allows you to do is that it allows you to store as much information as possible. Okay, so by just accessing Daniel as a key, you can store all information that Daniel has, and you can increase this information as much as you want. Even going down to this Jane, you can also see that Jane can also have all the information. And this information don't necessarily have to be the same for everybody. For instance, Jane can have a marital status. Jane can have a marital status. And we can say this marital status that she is single. Okay, so let's change this to a comma. So she is single. Her marital status is single. While other ones, they don't have that particular data. All right. So that is like the beauty of a dictionary. A dictionary can be used to store complex or very large amount of data. It can also be done with a list, but the structure that a dictionary gives to you makes it way more clearer than you can access it or than you can do with other kind of data type. So now, how do you access information that is in a list? For instance, now we have three keys here that also have their own values, right? So the way you access information in a list, or I mean in a dictionary, is to use the key. One of the ways to do that is to use the key. So you can now say family tree, then we open this square bracket. By just doing that, you will see that it makes the keys that are available for us, okay, in this place. So you can now say Jane. If we say Jane and then we'll print out this, let's print this out. Let's print this out and save it. Now, if you come here and say Python dictionary and run Python dictionary, now you can see that it prints out every information that was in Jane. Okay, every information that was available for Jane. You can see that she is dark in complexion, She has a height of 170. Her age is 22, and her marital status is single. You can as well print out just a single information. For instance, you can print out the telephone number of Jane. Okay, so we access family tree, and inside that family tree we access Jane, and because Jane gives us a dictionary, we can as well now access that dictionary that it gives to us. So we can now print this out again. So if you print this out, you should print out Jane's dictionary for us. I mean Jane's phone number for us. So it prints out Jane's phone number, which is this particular one. Okay. We can even go ahead to make it even more complex. What I mean is that assuming Jane has more than one phone number, okay, so we can now store all our phone number in a dictionary. I mean in a list. So we can store different phone numbers here. Let's copy this. Let's just copy this. Let's say she has more than one phone numbers. We can store all of them now. So you can see that this can be of another data type. That is how a dictionary works. A dictionary enables you to like store any type of value, any type of data that you want inside that particular key, to that particular key. So now that you've seen how to create a Python dictionary, let's see how to perform some operations, just like adding items, removing items, getting items from a Python dictionary. Let us see how we can do that. So let's look at the operation. So the family tree is a dictionary, and if you follow with the dot, you can see all of these methods that are available for us to perform operation in the Python dictionary. So let's take them one after the other. So the first method is clear. So if we call the clear method on this Python dictionary, what it should do is that it's going to remove all the items from the Python dictionary, right? So that is what it's going to do. Before then, let me just print out the Python dictionary so that you can see how it will show on our terminal. So I will comment this out and then save. So if I run this on the terminal right now, so you can see that it prints out every item on the Python dictionary for us. Okay, print out every items that are in the Python dictionary. Now we can uncomment this now and then also run it again. So let's run this again. First I'll clear the terminal and then I'll run it again. So as you can see, the dictionary is now an empty dictionary because that is what the clear method does. The clear method actually removes everything from the Python dictionary and return an empty dictionary back to us. Okay, so what is the next method that is available? Next method that is available is the copy method. Okay, so what does the copy do? The copy is usually if you want to create a clone of or another copy of this Python dictionary into a different dictionary. Okay, so let's say we create another variable here, and let's call this variable family tree copy. So family tree copy, and we equate it to the Python dictionary, Python tree copy. So let us print out this family tree copy and see what we are going to have. So we'll put this in our print statement here, and we'll call this to copy. So if we save this right now and we run, so as you can see, we've actually successfully copied everything that is inside this Python dictionary into a new variable. So you might want to do this if you want to perform an operation, but you don't want to change anything that is here, okay? Or maybe if you want to use some data in this Python dictionary without actually influencing or changing anything that is in the current state of that Python dictionary. So what you can do is to create a copy and then copy everything from here with this formula, with this method right here, and then send it to this new Python, to the new variable that you want to copy into. This will enable you to perform any operation you want to perform without actually changing the state of the current dictionary. Okay, that is what that one does for us right now. So let's see the next method. The next method that is available is the get. I will skip this because it's actually not relevant for us now. So I will get the get. So the get The get method, what the get method does is that it's used to get a specific item, or yeah, a specific item from, or a specific data from our Python dictionary. So if you come here and highlight, you will see that get, you pass in the key as a string, and it returns the key, the dictionary of that particular key for you. Okay, so it returns a dictionary. You pass in the key, which is as a string, and then you get the dictionary of that particular key. So if you go to our family tree here, you see we have Daniel, James, Jane. So assuming I want to get the dictionary of Daniel, so I will just come here and pass the string, which is Daniel. Okay, so I'll pass the string. So this will return a dictionary of that particular Daniel for us. So if we print that out, or let's just create another variable and call this Daniel. Let's create another variable and call this Daniel, and we create this to be equals to family tree. So if we copy Daniel and paste it in our print statement now, then we save it. So if we run this now, it should return Daniel for us. So it returns the dictionary of Daniel. So if I copy this and paste, you should see that it's the dictionary of Daniel. That is the information that is in the Daniel. Okay. So I copy this and paste. You can see this is a dictionary. This is what it returns. So it returns a dictionary of that Daniel key that was here. Okay. So assuming you want to get a specific, let's say a specific information, and you know the key, you can actually use get to actually do that, and then it will return that for you, right? So the next one we want to look at is family tree dot items. So what does this item method returns for us? So this method is going to return all the items that are in our dictionary. So let us run this. Let's just run this and see. Let's just copy this directly and put in our print statement and see what it will return for us. So let's see what this will return for us. So if I run this now, you can see it returns everything in a dictionary, a list dictionary for us. So it puts everything in a list and return it back to us. Okay, put everything in a list and return it back to us. So using this item, it will enclose everything in a list and return it back for us. You might likely not use this very much often. So I just wanted you to know what that can do. The next one we want to look at right now is the key. So this key will return all the keys that are in our dictionary. Okay, it will return all the keys, just like the item. It will return all the keys that are in our dictionary for us. So look at the terminal again. So let's run this again on the terminal. So as you can see, it returns a list of all the keys that are there. We have 3 keys: Daniel, James, and Jane. So it returns the keys of all those dictionary for us, right? That's very much amazing. So the next one is pop. So just like we have pop in our, just like we have pop in other collection like list and set, we also have pop in the dictionary. But the difference is that for this particular pop, it will not remove item from the end. In a list, when we are talking about a list, when you use the pop method, you remove item, the last item from the end of the list. But in dictionary, when you use pop, you need to pass in the key that you want to remove. So in this case, let's say we want to remove the key. Let's say we have James. So let's say we want to remove it from our list. So we pass in the key we want to remove the dictionary of that particular key for us from the dictionary itself. So if we run this now, if we print out our dictionary right now, you should see that we only have Daniel, which is here, and Jane. We no longer have James, which is what we popped out from here. That's actually removed that for us. Now there is another method called pop item. Okay, so let's use that one, pop item. So how does this method work? This method is an example of what we wanted to achieve, and it's similar to the pop in a Python list or a Python set. So this particular pop will simply remove the last item from our from our from our dictionary. So as you can see, it has removed. We are only left with Daniel and James. The pop item method here will remove the last item. So I don't want it to be just carry this in your mind so that you will not be very much confused. The pop item remove the last item from the dictionary. Why pop? For pop, you need to pass in a specific key that you want to remove, and it will remove that for you. Okay, so let's try the next method, which is family tree dot update. So this is the one I wanted to get to. Now, family tree dot update is used to add a new dictionary to our list. Okay, so let us create a new dictionary. Yeah, so let's create a new dictionary, and we call this dictionary village tree. So let us call this village tree, and it will be an empty dictionary for now. Okay, so if we print out village tree, what we should have is an empty dictionary. So if you run this, you can see that it prints out an empty dictionary. Now with the update method, we use the update method to actually add a new dictionary or to combine two dictionaries together. That is the right word. So we use the update method to combine dictionary together. So for instance, the family tree has items in it, while the village tree cannot add item, does not have item. So now we want to add the items in the family tree into the village tree. So the way to do that is to do village tree. So we can do village tree dot update. So we now have access to the update method, and then we pass in the dictionary that we want to update it with. So we update with family tree. Okay. So we're doing this now. We've carried every item in the family tree and we've added it to the village tree. So now if we print out the village tree, we should now see that it also have all the items that are in the family tree. So as you can see, all the items are here. Now it doesn't really matter if there was an item here. So let's say that the village tree has this particular dictionary in it. So let us change this dictionary to let's say Solomon. So this is Solomon dictionary right here. So what we do now is, what will happen now is that it will not override this particular item here. Rather, it will only add what is here to what already exists in the village tree. So if we run this again, you can see that we have Solomon, which is already in the village tree. And then we have other items that is coming from the family tree. Now the trick is that if there is a key that already, if there are two similar keys, like assuming we have, now that we have Jane here, assuming family tree also have a key called Jane. So what is going to happen is that it's going to merge what is coming from family tree to what is in here, and it will replace all of these keys here with the new value of what is coming from family tree. Okay, so let me change this now to 400. Let me change this now to 400, age 400. Now remember that in this particular one, the age here is 22. Okay, so what is going to happen is that it's going to use what is coming here. Since they are similar, it's going to use this to replace what is already here. So let me also change this to married so that it will be very much obvious. Now let's update village tree with family tree. Okay, so if we clear the terminal now and run this. Now if you go to Jane, which is here now, you will see that that's replaced 400, which was in village tree, with 22. The age is now 22. That actually also replaced married with single. Okay, so when you have a similar key, what is going to happen is that whatever is in this particular one will be replaced with what you're updating it with. Okay, so I just want you to understand that because it's pretty much important if you're doing something like a database update. Be very careful because it's going to replace what you currently have with what you're updating it with. So that's pretty much everything you need to know about a Python dictionary. Now, before we move on, there's one more data type that I want to explain. Now, if you go to our folder directly, you can move into the file now called PyJSON. The Python collection is something called a JSON. Okay, so you can go now to the collection folder and move to the file called py -colon.py. Okay, so now a JSON is something called a JSON is an acronym. I don't know if I'm pronouncing it very well, but some people call it JSON, some people call it JSON. Whatever you call it is still correct. So a JSON is an acronym for JavaScript Object Notation. Okay, so it is a data type that is very common in JavaScript, but which is also very important when you're working with a web framework and interacting with an API. So an API is also another acronym for Application Programming Interface. So I do not expect if you're a beginner to really understand what this is, but a introduction like this would prepare you for when you're working with it in web development. So when you are interacting with an API data are mostly returned in something called JSON and not in Python dictionary format. So it's actually returned in a JSON format. Okay, so Python does not support JSON natively, but we have a module that we can use to convert our Python dictionary to JSON or convert JSON to Python dictionary. Now, to use this module, as well as to use any other module in Python, you need to actually import it. And the way we import a module or a package is to actually use the import statement and then followed by the name of the package. In this case, the package is known as JSON in Python. So we import this JSON now. So I'm going to go back to our dictionary and I'm going to copy the data so that we can work with it. So if you go to this place, we can copy the family tree dictionary that we created already. So I'm going to copy this, then I'm going to go back here and I'll paste it. Now the first thing we want to do is to convert this Python dictionary to a JSON. Okay. So first of all, let us check the type of this. Let us check the type of this family tree. So if we come down here and we print type of family tree, to print this on our terminal, it should show that it's a dictionary. So run this. Sorry, I think there's a little mistake here. So it's supposed to be Python PyJSON. Yeah, it's supposed to be this Python PyJSON. Baba?
Sorry, I forget.
Okay. And they come. You don't open them?
Yeah, I open.
I don't open them?
Yeah.
Okay, they come.
Now, it's open.
Okay, I'm coming. So if we run this now, this should show that this is a type of Python dictionary, as you can see on the terminal. Now the way you convert a Python dictionary to a JSON is to use a method from this package known as DOM. So we can now come here and we can now say, let's create a new dictionary. So we can call this PyJSON, and we can equate it to JSON, which is the package we've imported, .dom. So we are going to use .dom. We are going to use .dom now. So let's do this first, and then we pass in family tree. Okay, and then we are going to print out this. We're going to print out this. Let's check the type first and see what we are going to have. Okay, so let's clear this and run it again, and you can see it's now of type string. That is because a JSON is actually of type string. Okay, a JSON is actually of type string. If we print out this JSON, you might not really see much of a difference, but it's actually of type string. Okay, so if we print out PyJSON now, print out PyJSON on our terminal, let's clear this and run this back. Now, as you can see, it returns back that same dictionary, that's the same structure of that dictionary that we had before. But the fact is that this particular PyJSON is no longer a dictionary that we had, just like family tree. It is now of type string. Okay, so by using this JSON.dom, we can now convert it from a dictionary, a Python dictionary, to from a Python dictionary to a JSON, which is of type string, and then we can now return it in our package. Now, if you want to convert a JSON back to a Python dictionary, what you do is using a method called JSON.load. So now that we've known that PyJSON is now of type string or of type JSON, what we can now do is to now say create a variable called whatever, what are family tree, let's just call it this, and we equate it to JSON.load. So JSON.load, and then we'll pass in PyJSON. So PyJSON now is of type string. So let's pass this out, and then let's print out farm tree. Let's print out farm tree now. And let us make this to be silent by commenting it out. Now, if we run this now, you can see that it returns also a dictionary back to us. Now, to be sure that this is actually correct, that this is a Python dictionary again, you can actually say type. You can actually run the type and then pass in farm tree. So pass in farm tree. Then let me clear this, and then you can see that farm tree is now of type dictionary. So using JSON.doms, you can convert a dictionary to a JSON, and using JSON.load, you can convert a JSON to a dictionary. Okay, so that is how you actually work with a JSON in Python, and it's pretty more simple and straightforward. If you want to study more about a Python, what a JSON is, I'm going to also drop a link at the description of this video and also in the GitHub repository, so that you can go through it and understand how to work with the JSON. But for now, this introduction is okay for this particular crash course. And that is the conclusion of our collection. What we are going to do next now is to go and look at conditionals, which is the next thing in this crash course. Now is conditionals, and so you can now enter, you can now open the conditionals folder and then enter the conditional.py file, and we can also do that in our terminal. So first of all, we'll move out of the collection folder and then we'll cd into the conditionals folder. Okay, so conditionals folder, right? So we'll do that right now, and then we'll clear our terminal. Now, conditionals are used in programming to direct the flows of a particular the flow of our application. So let me start with an example. Assuming you're building an alarm system, and what you want to achieve is that when somebody sets a specific time and date, your alarm system can only go off at that particular time. So if that doesn't work, that means you have not built something very correct. Okay, so you will use condition. You can use condition in programming to actually make that to happen. Another example is assuming you're building a subscription-based social media platform. Now, there are some features you might want to restrict for people who have subscribed. So only those who have paid subscription will be able to access that particular feature. Else, any other person that have not paid will not be able to access that. So for you to achieve any of this operation or any of these features, for them to work correctly in your system, you must use conditionals to like direct your program on how to do this. Now in Python, there are three keywords that we use to write conditionals in our program. The first keyword is the if keyword, which is used to set the first condition that we want to implement in our system. Now we have the else-if keyword. Now the else-if keyword runs if the first condition in our system is not true, it's not set to true, or is not correct. If the first condition does not match, then we use else-if to set the next condition. Now the last one is the else keyword, or the else statement as some people will call it. Now what this does is that if none of these two conditions run, then anything that is set in the else statement will now run. Okay, so now let's assume we want to build a security system or a security door, and we want people to enter inside that particular room if they are at least 18 years. That is the first condition, or they are above 18 years. Okay, so they will enter if they are at least 18 or they are above 18 years. Now if two of these conditions does not meet, they will deny that kind of person entry to that particular room. So now let's just implement this and see how we can do this. Now the first thing we want to do is we want to create the minimum age that the person must enter. So we create a variable, we set the minimum age, and we set the minimum age to 18, right? So this is the minimum age that we want someone to be before the person can access the room that the security door is being put. Okay. Now we now create another variable. We now equate this variable. Let's create this variable and call this person age, and this variable would be the age of people who wants to enter. Okay, we will imagine that when somebody wants to enter, the person will show his ID card or anything that we can use to extract age. Now, but for now, let's just set this to 0. Okay, now let's start writing the conditionals. So we'll now start with if keyword. Now the if keyword is accompanied with these two round brackets. Now inside this bracket is where you put your conditionals. So we now say if person's age is less than 18, or if person age is greater or equals to 18, or is equals to minimum age. Now if the person age is greater or equals to minimum age, what this means is if the person age is greater, that is bigger than minimum age or is equals to minimum age, then we want to allow the person to enter. Or we can even make this to a little bit longer so that we can check for the both condition into using the else if keyword too. So if the person age is equal to minimum age, that means if this person age is equal to minimum age, which is 18, we want to allow this person to enter. So we follow it with this column here, this double column, and we now print out something like you are permitted to enter. You are permitted to enter, right? So you are permitted to enter is because the person age is equals to the minimum age. Okay. So what if the person age is not actually 18 or is not up to minimum age? What can we do? We can now use the else if keyword now, and the else if keyword also accepts a condition. So in this case, we want to check if the person's age is greater than minimum age. So since this person age is not exactly equals to minimum age, let's now check if the person age is greater than the minimum age. So if the person age is greater than minimum age, that is fantastic. We also want the person to enter. Okay, so we will now also print you are also permitted to enter. Okay, so if the person age is equals to minimum age, you are permitted to enter. If it is greater than minimum age, you are also permitted to enter. Now finally, the else statement. Now the else statement does not accept any condition. Rather, it will run if either of these conditions are not correct. Okay, so we will now say, finally, we will now say you are not you are not you are not permitted to enter. So since the person age is not equal to minimum age, or the person age is not greater than minimum age, that means the person is not permitted to enter. So let us run this file right now and see what we are going to have. Remember that currently the person age is equals to 0. Okay, so the person is possibly maybe a toddler, and is not yet equals to, does not yet have a complete age, if that is correct. Okay, so we now do Python conditionals dot py. So as you can see, we print out the system print out you are not permitted to enter because the person age is actually not equal to minimum age. So let us set this to the minimum age, which is 18. Okay, we'll set this to 18 right now. If we clear and then we'll run this again, you can see that the person is now permitted to enter because it matches these conditions which is here, which is equal to the minimum age, and then also permit the person to enter. So what if this person age is equals to 20, which is above the minimum age? Then what also happens again? Let's check it out. Now you can see that you are also permitted to enter. Now we use this kind of system to like conditions how our program should run. Now most often it will not print and you will not add a print statement. So it could be like a function that will be running. So we will not talk about functions, so I do not want to complicate anything right now. But imagine this to be like a security door. Imagine this to be like a security door. If the system is equals to minimum age, if the person age is equals to minimum age, then something will run which will make the door to open, okay? And the person can simply walk inside. And now, if the person age is also greater than the minimum age, then the door will also open and the person can walk inside. Else, if this condition is not met, then the door will stay closed and the person will not be able to enter. When we get to the section on function, we'll come back to this and then we'll create some function and then you actually use it to make sure that we replace the print statement with that. But at the minimum, that is how conditionals actually work in Python. And I hope that was clear enough for you to understand. Okay. And the next thing we are going to look at now is for loop, and we are going to look at that shortly. Is a loop. A loop is very important in programming because it enables us to like automate some tasks. It enables us to automate tasks and make us to perform some tasks that would have otherwise been very, very tedious. Okay, so I'm going to show you how to perform looping in Python with an example. Now in Python, there are actually three ways to actually perform a loop. The first one is for loop, the second one is the while loop, and the third one is using something called a range. And we are going to look at this one after the other. Now remember when we talked about a dictionary, I mean a list, and we have the scores of students like this. So we have the scores of students like this. And then so I'm going to rename this to score list. Now imagine if you want to add extra marks to all the students that are here. Imagine if you want to have extra marks to all the students. Let's assume you have more students that score different marks, okay? And you've been encouraged or you've been advised to add more scores to maybe like 20 more scores or more marks to all the scores that are already here. Now, one way you might want to do that is to try to assess each of these items individually or manually, the way you do score list. Score list, maybe assess the first item and you add an extra mark to it, okay? That could be very tedious, but with a loop you can do that very fast. So I'm going to show you how to do this now with a while loop. So now let's create a new dictionary, a new list, and we are going to call this new score. We are going to call this new score, and for now it's going to be an empty list, but at the end it's going to hold the new score of every student or every score in this space after adding the extra 20 marks to it. Okay, so the next thing we are going to do now is to use a for loop to iterate over all these lists and then add 20 marks to each of them. So what we are going to do is to use the for loop. Now the for loop uses two reserved keywords. The first keyword is the for keyword and the next keyword is the in keyword. Okay, now let's assume that every score here is an item. Okay, so let's assume that every score in this score list is an item. So what we can now do is to say for item in score list. For item in score list. Now this item here can be anything. You can call it whatever you want to call it. You can call it maybe X, you can call it Y, you can call it Z or anything. But it will represent each items that are inside this particular list, which is a score list. Okay. So after that, you follow with this a colon, and then you perform whatever you want to perform. Now what we want to do is that we want to create a new variable, and we call this variable score, and then we are going to equate this to item plus 20. So what we are doing here is that when we get a particular item, we add 20 to it, we add 20 to it, and we assign it to a new score. So what in essence, when we get to 20 here, we add extra 20 to it, and then we assign it to a new score. When we get to 13, we assign 20 to it, and then we assign it to a new score. When we get 24, we add 20 to it, and then also assign it to a new score. Finally, what we want to do is to say new score dot append score. Okay, so what we are doing now is that, since this is a list, we have access to the append keyword. What the append keyword does, that it add item to the end of the list. Remember that when we are talking about the list. So again, what we are doing here is that when we get an item in this score list, we add 20 to it, then we assign it to a variable called score, and then we append that score to a new empty list, which was 20. Okay, then when we get to 13, we add 20 to it, and then add it to the end of the new score list. Okay, now if we print out new score, we should have a list containing the score of the student, but with 20 added to each of them. Okay, so let's print out the new score, and let's also print out this score list so that we can compare both of them together. So score list here, new score list. Okay, so if we say Python loop.py, and I'm using loop.py here because the file is named loop.py. Okay, so if I print this out now, you can see that here we have 20, but in this place we have 40 because we added 20. Here was 13, now we have 33 here. Here was 24, and we have 44 here. Here was 56, then we add 20 and we have 76. Here was 70, we add 20 to it, we have 90. Okay, so a for loop uses the in keyword to actually iterate over. You use the for and the in keyword to actually iterate over a collection. Okay, so the collection can be any kind of collection. It can be maybe a dictionary, it can be a set, and so on. And then you can use your for loop to actually do that. Okay. Now there's also a break statement that accompanies for loop. So if you want to stop iteration when you get to a particular place. So let's say we say when we get to item that is equals to like 13. So we can use our if statement. Say if item equals something like 13. If item equals 13, then we can break. So what will happen is that it will skip over the loop. Okay, it will skip over the loop at this particular place if item is equal to 13. Okay, so that is what this particular guy will do. Once we get to an item that is equal to 13, the break statement will stop the loop from going on. There's another one called continue, another statement called continue. Now what continue does is that if you get to a particular condition, it will skip that particular guy and then continue from the rest. So for instance, if you get to an item which is 13 like this, it will skip over this and continue from 24. That is the meaning of continue and break. So depending on where you want to use any of this. Alright, so that is how a for loop works. Now the next one is a while loop. Now a while loop is used when you don't really know the conditions that when you know the condition that you are performing something for. Let's say you know that you want to perform an operation to a specific number of items, or you generally know the condition that you are trying to do, that you are trying to iterate for. That is when you use a while loop. So a while loop uses a reserved keyword also called while. So how it works is you write the while keyword and you follow with the condition. So now let's say we want to print from like 1 to 10. Okay, we already know that we want to stop at number 10 or number 20 or so on. We already know the condition. So we want to print a number from 1 to 10. So since we already know the length of the item that we want to print for, a while loop is suitable for that condition. So how can we print a number from 1 to 10? The first thing we can do is we create a variable called counter, and we give this counter to 0. Now, why counter is less or equals to like 20? We want this condition to run. We want to print we want to print counter, and then we want to increment counter. So we want to increment counter here equals to counter plus 1. Now let me explain what this will do. Now we have an item, we have a counter here, a variable called counter, whose value is 0. Now we want to print a number from 1 to 20. Okay. Now we set a condition inside the while loop. We say why the counter, that is why this counter is less or equals to 20. We want to print it out. Okay. So at 1, it is less or equals to 20. It is less than 20. So we print it out. At 10, it's also less than 20. At 19, it's also less than 20. But at 20, it is less or equals to, or it is equals to 20. So we want to end. Now for us to increment the value of that counter, we have to add 1 at every time that the counter is printed out. So when the counter is like 2, when the counter is 0, which is default now, when the counter is 0, this line here will add 1 to 0. So this will be equals to 1. Okay. Now in the next iteration, counter is now 1. Okay. This line will now add 1 to it. So it will now be counter plus 1, and this will give us 2. The next iteration, counter will now be 2. This line will now add 1 to it. So if you add 1, counter will now be equals to 3. So what this line does is that at every iteration, it increments the value of counter by 1. Okay, so that we'll be able to get to 20. Okay, now let us print this out now, and I will extend our terminal. If I clear this, you can see now that we have from 0, which is the default value here, and we can now count from 0 to 20. Okay, so that is how a while loop works. The while loop actually prints out every item, and you can use both while loop and for loop for every collection to print out any collection that we have. Okay, you can use that to print out items in any collection that you're working with. All right, and it will work out very quickly. Now, the final one I want us to look at is a range. Range. Now, what range does for us is that it works like a for loop, but it enables us to print out items in between a range. So the way that works is for x, let's say for item in range 100. So print item. Of course, to show that you can use anything here, I can replace this with number. For number, print number. Okay, so because like I told you initially, you can use any letter or words in this place. So what we are saying here is for any number in range, for number in range 100, that is between 0 to 100, print out that number. Okay, that is what this guy is saying now. Now if we do this now and print it out, we do this and print it out now, it's going to print out every number from 0 to 100 to 99. Okay, so it's going to print out every number from 0, which is the range from, the starting range, to 99, which is a number between 0 and 100. Now a range also accepts 2 other numbers. For instance, we can say 2, 100. Now what this will do is that it will start from number 2 instead of starting from 0. It will start from 2 and get to 100. The next thing we can also add is here 2. Now what this will do is that it will skip 2 after each iteration. For example, when it starts from 2, it will skip 2 and then print 4. When it gets to 4, it will add 4 to 2 and then print 6. You understand? So it will keep adding 2 to the number that is printing out and then print the next one. Let's show this practically as how it works. So if we close this and now run this, now you can see that it starts from, okay, that's not it. So it starts from 2, after 2, 4, after 4, 6, after 6, 8, after 8, 10, after n, 12, and so on and so forth. That is what this particular number does. This one allows us to start from 2 and then this one allows you to skip add 2 after each iteration and print out the number. So where we use for loop mostly is when we are trying to iterate through a collection, maybe like a dictionary. We want to iterate through a dictionary and print items in the dictionary. That is when you can use your loop to like do that. So anytime you have a collection of stuff and you want to print out those items, or you want to perform an operation on those items, you can use a for loop to iterate and bring every item of that particular collection and then perform an operation on them. Okay, that is what a for loop. So we've just gone over the three ways of actually iterating or actually performing a loop in Python, and it's quite straightforward and very easy when you use them in actual projects. Okay, so the next thing we are going to look for now is look at now is function, which is very important in every programming that you are doing. So we are now going to look at function and see how we can create and use function everywhere in our code. Is a function in Python. So generally in programming, a function is a piece of code that performs a specific task. Okay, so imagine if you want to loop across any list of data that you have. So remember the looping that we did that we performed here. So imagine if there are a lot of lists like that in your code. Maybe there's a list in dictionary, there is a list in your operators folder or your operators module. There's a list all around your code, and you want at each of these lists you want to perform an operation, maybe the same operation that we perform in this place. Now, the first one approach you might want to do is that one approach you might want to follow is that at any time you see a loop like a list like that, you write a loop for that. Maybe you write a for loop or a while loop for that. But that will not be correct because there are two things that can happen. The first thing that will happen is that you are repeating yourself, which goes against a very important principle in programming, which is do not repeat yourself. So do not repeat yourself principle encourages you not to repeat code that you can actually write in a single place. Another problem is that when you repeat code often and often, it will make your entire code to become unnecessarily large and can lead to introduction of bugs to your code, which is not really a pleasant stuff. So what you can do is to write a piece of code that you can use to perform a loop wherever you need to perform that. So maybe in our loop file here, you can just call that particular code and it will help you perform that loop for you. So that is what a function does for you. So in programming, a function is a piece of code that you write to perform a specific task. So how do you define a function in Python? You define a function in Python with the def keyword. So the def keyword is a short form of definition because this is the point where you define your function. So in this, you follow that with the name of your function. So let's say we want to perform loop, so we can call this function perform loop function. Okay, and then you follow that with these two brackets and then a colon. And then a function is usually going to end with something called a return statement. Now, a return statement is used to return the result of what your function has done, or the result of what your function has done. So, for instance, since this particular function is going to perform a loop and is going to add 20 to each of the items, so this function is going to return the new list that we are creating after the loop. Okay. Of course, a return statement can return anything. It depends on you as a developer or what your system requires or what your building requires. So, but your system or your function rather should always return something. So now, your function can also take something called a parameter or sometimes called an argument. Now, an argument is a set of or a data that you want to use in your function. Okay, an argument is a data that you want to use in your function, and it can accept any amount of data that you want to pass. Some function might not accept data, or you might not need to pass in data here, while some function might need to pass in data. For our own, our function will need to collect a list. Okay, our function will need a list so that whenever somebody is using it, the person will have to pass a list of items or a list of score or score list, whatever you want to call it, score list to this particular function. So what we want to do is that we want to repeat the same thing we did right here. We want to repeat the same thing we did right here. So we can copy this right now and we'll take it to our function, and let's just paste it somewhere here. So what we want to do is that whenever we get a list like this, we'll iterate over this list and then we'll add 20 to it. So first thing first, we'll have to create a new list. So we'll create a new list and we'll call this new score, just like we did previously, and this will be an empty array or an empty list. So we'll now look for every score in the score list, that is this particular one that will be passed to our function. For every score in the score list, we want to add it. We want to add 20 to the score and then assign it to a new variable. So we want to call this variable item, and then what we want to do now is to be score plus 20, right? The same thing we did previously. And then finally, we want to say new score dot append that item. Okay. Now we've successfully defined our function. The final thing we want to do is that we want to return a new score. So it return a list. Now we can literally return whatever we want to return here. So we might decide to maybe return a string and say something like completed. Okay, you can say something like completed. The return statement doesn't really care about what you've done in your function. The return statement return whatever you want this function to return. Okay, at the end of the day. But of course, we want this function to return the new list after a score of 20 has been added to each of these scores. So at this point, we've successfully defined our function. Now, for us to use this function, we have to invoke this function. So in this case, to invoke this function, we call the function name perform loop and then followed by these brackets that comes. Now, inside this bracket, because this our function require us to pass a list, we have to pass the list that we want to perform an operation on. So we have to define the list, which is this, and we call that function with that particular list. So maybe we can now assign this to a variable. We can say data. Let's just call it data and we put it to this particular one. Now, if this our function did not accept any parameter here or argument here, we wouldn't have passed any parameter to this particular place. Okay, we wouldn't have passed any parameter. But the reason why it is accepting this is so that whenever this function can be used at any place. Okay, this function can be used at any place. So whenever somebody needs to perform a loop, and whenever somebody needs to perform a loop, yes, on a list, you can simply use this our function and we'll pass the list to it, and our function will perform this operation for it. Okay, so in this case now, if we print out data, which is what this function is going to return, we print this out and then we run Python function.py. You can see that it's going to return this for us. Okay, so the result of this printing will be what our function return. So if we come here and say good morning, if we return good morning here, if we return good morning here, and then we run this our operation again, when we call this function, is going to return good morning. Okay, so the result of what our function will return is not necessarily what our function performs. It is what we add to our return statement. Okay, so you have to be very careful of this. Our function will not return the operation it performs. Okay, it is simply going to return the instruction or the data that we say it should return. Okay, the reason why it returned score list initially was because, the reason why it returned a list was because we say it should return the new score. So be very careful or be very mindful of this. The return statement will return whatever we ask it to return, regardless of any kind of operation that our function has performed. Okay. Now we can use this function in any part of our code, by simply importing this function to that particular place. Now, because of the structure of this my project now, I would have simply show you how to use this function, but I will give that as a task for you. But first thing I'm going to tell you is that you need to know what relative and absolute path is so that you can be able to import this function and use. However, this function now can be used across all our code and it will be successful. Let me show you, maybe I should show you a simple example. So let me create another file here. Let me create a new file. I'm going to call this form.py. I'm going to call this form.py. And this is a new folder, but it's in the same, this is a new file, but it's in the same folder with our function.py. So inside here, I can simply import function now. I can simply import function, which will give me access to this file now. Okay, which will give me access to this. Now, let me copy this call list now. Let me copy this. Let me copy this now. Okay, and copy this and go to this new file and paste it. So imagine this is a different part of my project, and I want to perform an operation. I want to loop over this and add 20 to it. So I don't necessarily have to create a loop for this again. I can simply use the function that was created in this function.py file. Okay. So inside there, since I've actually imported this function now, I can now say something like, and because I've imported these modules now, I have access to everything that is inside that module, including the function itself that was defined there. So I can simply say something like this now. I can simply say function, which is this, dot perform loop. As you can see, I have access to data, I have access to perform loop, I have access to score list, which is also defined in this place. Score list is there, data is there, perform function is there. So you can see that I have access to that, but what I'm looking for now is the perform function, and then I can pass in my score list. Okay, I can pass in my score list. So if I print this out now, let's say print. If I print this out, and then I come here and say not function.py again, but this time func.py. If I run this now, it should actually print this out for us. So it's going to print that particular output for us. As you can see down here, it's actually going to print it out for us in this place. Okay, so now I can actually use my function anywhere without having to create this function again. Okay, I can use this perform function everywhere without having to create this function. The reason why this is running 2 times is because we call this function in this place. We call our function here. So I can silence this right now and maybe run that again to see. You can see right now it's actually printing just one. Okay, it's actually printing just one. So with that, creating function at a particular place, you can use it in any place. Now, if there is an error when I perform this, I can now simply go to where that function was defined and then look for where the error is coming from and just fix it, instead of repeating the code, trying to write the same code over and over again. One last thing, when you are defining a function, we call that state function definition, and when you're using that function, we call this function invocation. So I just wanted you to know that. So that is pretty much what you need to know about function, because it allows you to like group your code into a specific task. As a personal preference, I also advise that a function to perform just a specific task. So don't overload your function with different things. What I mean is, for instance, this perform loop, you shouldn't perform a loop and then do something else. You should just perform one single task so that you will know that each function is doing this particular stuff. Instead of you to overload your function, you can create multiple functions that perform multiple tasks so that you will always be able to catch where your problem is. So that is everything about function. We are almost at the end of this tutorial. One last thing we are going to look is classes in Python and how to create class. See you in that room. In this section, we are going to cover classes in Python. Okay, so classes or class in Python are very important concepts of programming, because it's not just in Python but in other programming languages that support object-oriented programming, because classes allows us to actually create our own custom data type that we can use all around our project. Okay, so think about this. Imagine if you want to create a data type that holds the type of car, or that holds the data of the type of car that will be displayed on your car listing platform. Okay, so you want to collect specific information about that car. A dictionary might not be able to allow you to do that. A list might not allow you to do that. So what you need to do now is to create your own custom data structure that will hold that particular class. I mean that will hold that particular information. A class allows you to do something like that. But not only that, a class also allows you to actually add your own custom method, which I'm going to show you how to do. So how do you define a class in Python? The way you define a class in Python is you use the class keyword and then followed by the name of the class. In this instance, let's say a car, which is going to be the name of our class. Now, with this, somebody can actually create a data structure or a new data using our class called car, okay, or using our car class. Now, one of the things our class or our car will need features, okay, we need certain properties. For instance, our car will need a name, we need the model, we need the year of manufacturing, and might need the mileage, okay. So to enable somebody to pass in this information when somebody is creating data with our car class, what you need to do is to use something called a constructor. So Python gives us a constructor and it's called init function. So the way you define that is to start with the define keyword and then double underscore init. And of course, when you enter, it brings this automatically for you. For now, I'm going to return this. I'm going to clean this. So inside this init function now, you can pass in all the properties that you want to accept when somebody is defining with, when somebody is creating an object of this class. And don't worry, I'm going to tell you what an object is if you don't already know. So first of all, I'm going to pass in name here. I'm going to enter name. I'm going to enter model. I'm going to enter the year and then the mileage. I don't know if that is the correct spelling of mileage anyway. So to complete this, I'm going to say self dot name is equals to name, self dot model is equals to model, self dot year is equals to year, and finally self dot mileage is equals to mileage. Okay, now this is a Python constructor, and when somebody is actually defining a class or when somebody is actually trying to create an object with our car class, the person will have to pass in this information. So before I even add more details, let's go on and create our car instance. Okay, so we can now say new class, new car is equals to car. New class or new car rather is equals to car. Now, when you do this, you can see that it requires a name, a model, a year, a mileage. Okay, so we can now put name. The name, which is going to now be Honda. I don't know, maybe Honda is one that came to my head. And this S class, which is the model. S class is the model, and then the year 2024, and then finally the mileage. Mileage is 1000 kilometers or 1000 kilometers. All right, so that is the mileage. Now, if we print out, we can now print out our new car. Our new car. Let's print this out and see what this will give to us. So first of all, we move into our car class, our car folder. So let's move out of this, then move into 8 classes. So now we can now run Python classes.py. So as you can see, we have an object of that particular class. Now, just like we have things like list, dictionary, and so on, we can now also check the type of our new class. Our new car, I tend to confuse both of them. So if we check the type now, you will notice that it is now of class car. just like we have that of list. This is now of type car. Okay, so we've successfully created a class, but that is not just the only thing we can do with a class. Now we can also add our own method. Remember when we are using a list, when we are talking about a list, or if you've come across a list, not even in this tutorial, remember that when we define a list, let's say score, and we equate it to a list, remember that we now have access to a lot of methods in that particular list, like append, like clear, and so on and so forth. So we can now also have our own method. We can have something like that. Now to add a method is just like defining a new function. So we can now say add car, add car. So what this function will do now is to add a new car to our car list. Okay. So this will return whatever I want to return. Okay. For now, let us just return a statement saying car added. Car added. Before I go further, a function that appears in a class is called a method. Okay, a function that appears in a class is called what? A method. So it's no longer called a function, it is now called a method. Now, any method that is added to the car class, can now be accessed by any method or any object of that particular class. I hope you get that. Any function that is added to a car class can now be accessed by any method or any object rather of the car. Now, an object is an instance of a car. When we talk about an object, we are saying an instance of a car. So for instance, this new car is an instance of this car class. So it is called an object. Okay. So every object of a car or any object of a class will be able to access every methods that are available in that class. So in this case, new car can access the add car function or the add car method. Okay, we can now access it just like we were able to access the append method, the clear method in our list. Okay, just like we are able to do this, we can now be able to also do this now. Okay, so if we run this now, yeah, let's replace that with this. Sorry, so I get to clear this now and run it again. So it takes what one was given. Okay. Now there is something we missed. Every method of a class should actually accept the self. So this is like a personal attribute or a custom attribute that every method that is in a class in Python must inherit. Okay. So anytime you define a method in Python, you must be able to put in the self attribute or the self property. Okay. This is like something you just need to do whenever you're adding a method. Okay. So let's run this again. Now you can see that it returns car added, which was the method that was added here. Okay, so you can add as much method as you want depending on what you want to do. For instance, maybe you want to add a function that will add new car. You want to add a function that will remove new existing car. So you can do something like this: define remove car. So this function takes self and then it will also return or perform a particular step and then return car removed. So you can add as many methods as you want to your car class, okay, and that will actually perform the function. Now, when you add a method, you want to write the logic of what that particular method is going to do. Remember when we do clear in list, it removes every item that was in that list. So when you do add car, you should also add item to that particular car. When you do remove car, you should also remove a car from that particular class or from that particular object. I will leave you to do that yourself. But as an example, you can do something like this. Since this is, we can add a function like this. Say, let's add a new function that returns the name of the car. So, or the manufacturing date. So we can call this function year, and we take self, and then what this function is going to do is simply going to return self dot year. It's going to return self dot year. So whenever somebody call this function, it's going to return the year that the car was manufactured. Okay. So if we come here now and then call year, yeah, call year in this case. So we should get the year that this particular car was manufactured, which in this instance is 2024. Okay. So if you do this, now and run. Okay. So there's a mistake here. So there's a mistake. So instead, let us do this. Let's rename this to let's add maybe something T here. Let's just add something T here, yeah, and then in this we add T here. So when we do this now, it returns 2024. The reason why when we did year it throws an error was because whenever the instance of a class or an object of a class does not just have access to the method of the class, okay, it also have access to the properties of that particular class. Okay, so when we did year, yeah, we are trying to return the car year. Okay, so what I mean is that since we've defined this particular car now, we can now access each of these properties individually. For example, we can access new car dot model. New car dot model will return the model of that class. New car dot mileage will return the mileage of that particular class, which are the properties of the new car. Okay, so an object of a class does not just have access to the methods in the class, it also have access to the properties of that particular class. In this instance, the car name is Honda, so we can have access to the car name, we can have access to the car model, we can have access to the car year and the mileage, which are all the properties that we actually set in the constructor. Okay. So one last thing before we call this a wrap. Now, a class can also inherit other class. Okay, a class can also inherit other class. So now let's assume this is a car and we want to create another method or another class of a different type of car. So we can call this a sport car. A sport car. Okay. So now a sport car we have all the properties of a car plus extra features, or it will have all the features of a car plus extra features that makes it a sport car. Okay, so let's say for instance the sport car has a method that says run or that says speed. So this method will return the speed of the car. So let's just say it returns fast. Return the speed of the car. Now, we also want this sport car to also have the properties or the features of the car. So the way we can do this is to make sure that this sport car also inherits from the car class. So in Python, that is quite easy. You can simply come here and then add the car inside this. So add the name of the class that you're inheriting inside the one that is inheriting it. So by so doing, the sport car now has the ability to actually inherit from the car class. So as an example, let's create an instance of the sport car. So we can now say sport car, which should be a new instance of the sport car. So we can say sport car. Okay, this will be sport car. Now you can see that it requires you to also pass the name, the model, the year, and the mileage, which was not defined in this particular guide, but was defined right here. Okay, it was defined right here. Now, not only that, this sport car class now, this sport car object right now also have the ability to inherit other methods. For instance, it has ability to inherit the remove car method, as well as any other methods that are in the car class. Now, not only that, a class can inherit more than 2 or 3 other classes in Python. So if there are other classes that you want your car or your new class to, or the sport car class to inherit, you can actually add all of them. So assuming we have another one, say car 2, you can actually add that here. It's not actually available, that's why we have this error. So a class in Python, you can add methods that will perform specific things in your class. You can also add methods that will do other stuff in your class. Before we go, I want to perform one of my favorite example when it comes to class, and that is a simple bank account. A simple bank account class. So we are going to create a bank account that add money to an account, deposit, withdraw money from the account, and also return the current balance of that particular account. Okay, so to do that, we start with a class just like I've explained, and then we give the name, we call this bank account. Okay, bank account. Now we are going to define the constructor. So the constructor is going to be this. Define the constructor. Now the constructor is going to take the name of the customer, the name of the customer, the name of the bank, the name of the bank name, and it's going to take okay, let's just keep that for now. So we'll remove this because it's not needed. So we are going to start again to populate the constructor. We say self.name, which should be customer's name. So let's say this is customer's name. This is customer name. So self.customer name is going to be equals to customer's name, and then self.bank name is going to be equals to this bank name that is going to be passed, right? Then that last stuff I want to add is the charge, so that there will be charges. Okay, charges. I'm going to set that to maybe $30 for now. Okay, now what are the features of the bank account? So you want to be able to deposit money. That is the first thing you want to be able to do. We are going to define a method called deposit fund. Deposit fund. Okay, and this method is going to, what it's going to do is that it's going to actually add money to an account. And that reminds me, we also need to add the customer's balance, the account balance of the customer. So we call this account balance, or let it be a custom feature that will be here. So self.account balance. For now, the customer's account balance should be 0.0. That is, there is nothing in the account. So this method is going to take an amount of money. Okay, when a user wants to add money, so it's going to take an amount of money, and then it's going to add it to the customer's account. Okay, so how are we going to do that? We are simply going to take these properties and then add the new amount to it. So we are going to say equals to amount that the customer is adding plus what is already there. Okay, so we are going to take the current account balance and we are going to add the amount plus the account balance to the account balance. Okay, that's what we are simply going to do, and this function is simply going to return the account balance. So it's going to return self.account balance. That is what it's going to return. Now the next function is withdraw fund, because your account should also be able to withdraw fund. So withdraw fund. So it's going to take the amount also. It's going to take the amount also, and then we are going to do something similar to this. So I'll just copy this. I'll just copy this and I'll paste it here. So, but instead of adding the amount of money now. So what we are going to do rather is going to be self.account balance minus the amount. So it's going to take the account balance and it's going to minus the amount that we are withdrawing. And then we might also want to add charges. So when you're withdrawing funds from your account, the bank wants to add their custom charge of $30. So in this place now, we will add the total amount that will be leaving your account will be the amount you're withdrawing plus the charges. Okay, it's going to be the amount you're withdrawing plus the charges. That is what is going to be withdrawn from your account, and then it's going to withdraw or it's going to return your current account balance. Okay, now finally we want to also add a method that returns the bank balance. Okay, so this method is simply going to return self.balance. Okay, so it's simply going to return the balance. Maybe we can also add another method that return account name. So self is going to return self.customers name. Okay, that's going to return self.customers name. Alright, so this is the 4 methods. First of all, we create the constructor, then we create a method that will add fund, then we create another method that will withdraw fund, and then we create another method that will check balance and also return the account name. Now let us create an instance of our bank account. And this instance is just like, let us create, imagine when you're going to a bank, now you want to create an account balance. So this is what we want to do now. So we can create a variable called somewhere, and then we equate it to the bank account. Okay, so inside this bank account, now what do we need to pass? We need to pass the customer's name. In this case, somewhere is the customer's name. And then we also need to pass the bank name to First Bank. So that is the bank name. By doing this, we've actually successfully created an object of this class. Okay. Now, what do we want to do? The first thing we might want to do is to check. Let's just check the current balance of somewhere. So we can now print somewhere dot balance. So because we have access to the balance method now, so we can call the balance method on this particular guy. So if we print this out now, you'll see that the current balance is bound method. I think there is a problem. Okay, so before we do this, we need to like fix an error here. We need to fix an error here. So this is not supposed to return self.balance because it's actually going to return back the balance here. Instead, what we want to return is self.account balance. So that is the correct thing we need to return. So we have to return self.account balance whenever we call the balance method, right? So whenever we call the balance method, S, that will keep calling itself. Okay. So what we need to do is to actually return self.account balance. Okay. So if we run this now, the current account of the owner of Samuel is 0.0 because there's no money. Okay. Now we can now call the deposit method that is available. So we can now say Samuel dot deposit fund. So what is the fund that we want to deposit? Okay, so we want to deposit maybe 5,000. So we want to deposit 5,000, maybe it's in dollars, rupee, naira, or whatever. So When we deposit that, we want to call the account balance again. Let us call the account balance again. So you can see that initially the account balance at this point was 0.0, but when we added 5,000, the account balance is now 5,000 naira. Okay. Now we want to also call the withdraw method. So Samuel.withdraw method and withdraw fund. Now we want to withdraw maybe 3,000, and then after doing that, we also want to call the balance method again. So if we do this, you will now see that at the beginning our account balance was 0, and then we added 5,000 to it. Our account balance become 5,000, and then we withdraw 3,000. Without the charges that we add here, our balance now is now supposed to be like 2,000, but because we added the charges that was here, our balance is now $1,970. Okay, so that is how to actually create a class and actually use a method. Now you can use this class whenever you want to create an account balance, or whenever somebody wants to create an account balance anywhere around your project. So I hope that was useful enough, and I hope you learned a few things in this very short course. Thank you, and see you in the next one.